All right, so today will be the final lesson of calculus. Well done, guys. We're going to finish on an easy note. This is going to be pretty straightforward. Again, I just want to say how awesome you've all been, how you've stuck with it. I really wish we could have had a normal semester with you guys. I think we would have had a lot more fun, but I did enjoy getting to know each and every one of you. And again, just thank you for all being so awesome. All right, so here we are, tabular integration. So just as a review, I am going to have the integral of x squared e to the x dx. So this problem we had done the other day, and this is the one where we had to do the integration by parts twice. And so just to recap, what we had done is we established a u and a v prime, and then we found the derivative of u and the antiderivative of v prime. And so we got x squared, 2 to the x, and then e to the x and e to the x. And so the integration by parts goes uv minus the integral of u prime times v, or v times u prime. I just switched it because I wanted to, dx. And then here I have another product of two terms, so I had to do it again. Remember to distribute that negative, take the integral, and done. So I just want to show you the pattern here, is that we have x squared e to the x minus 2x e to the x plus 2 e to the x plus c. And as we change with our x values, I'm noticing that the derivative, here's my original term, the derivative is here, and the second derivative is there. And then if we work from the other direction, we'll pretend that this was the second derivative, and then the integral or the antiderivative of it was e to the x and e to the x. So this example doesn't show it quite as clearly, but you can see the progression of the derivatives and the progression of the integrals as we combine them. And so a mathematician realized that there must be some sort of connection. And so here is tabular integration. We make our u's and our v primes, and down this column will be all of its derivatives, and down this column will be all of its integrals. And then what they noticed is that if we just do a little multiplication, we get the same three terms. And then to address the minusing part, you'll notice that with the integration by parts, the first term is positive, the second term is negative, and then the third term, the double negatives, make it positive again. So there's going to be I'm going to call it alteration, but that's not the word I'm looking for. But we're going to be alternating. There it is. We're going to be alternating between positive, negative, positive, negative. Now, that doesn't mean that every first term will be positive. It's dependent on its derivative and its integral. But in general, we can give it a multiplier of a positive or a multiplier of a negative because of this sign. And so if I go through and do the x squared times e to the x and multiply by positive, plus 2x times e to the x multiplied by negative, 2 times e to the x multiplied by positive, finish off with c, I would get the same result as I did by doing the integration by parts twice. Pretty simple. So let's take a look at a new example, x cubed sine x dx. So this technically would have had to have had an integration by parts 3 times. So first with the derivatives, I'm going to start off with x cubed as my u, and I'm going to take the derivative, take the derivative, take the derivative. I'm now done. We always stop at that constant. Now here, I'm going to take the antiderivative. So the antiderivative of sine x is negative cosine x. The antiderivative of negative cosine x is negative sine x, cosine x, sine x. If you're not sure or you started to get confused with what is what, remember to go back up this column would just be taking the derivative of each term. So the derivative of sine is cosine, the derivative of cosine is negative sine, the derivative of negative sine would be negative cosine, and the derivative of negative cosine is positive sine. You can always double check your antiderivatives by taking the derivative. And now I'm going to go ahead and do my pattern. So I'm going to multiply by a positive 1, we'll call it. Multiply by a negative, multiply by a positive, multiply by a negative. And then I get these 4 terms with my plus as my 5th term to be the final answer. Now, you could use integration by parts, but obviously that would become extremely tedious and gruesome. So I recommend just alternating between plus minus, and plus minus. So your final homework is 4 problems. It's found in the book, numbers 21 through 24. I will warn you that some of them may have the chain rule involved when working with the derivatives and the antiderivative. So just be very careful with that, and good luck. Again, thanks for being so